Hello and welcome to this first tutorial on how to program with JavaScript to the HTML5 canvas. If you want to create a video game, or maybe a physics simulation, a drawing application, or even a simple animation, then this video is for you. Now I haven't geared this towards absolute beginners, but if you are one, I do think you could still get something out of watching this tutorial. Just follow along, and if you find something that confuses you, press pause, look it up on the side, and come back at your own speed. With that said, we'll get started. The first thing I'm going to do is create an HTML document somewhere on my computer in a dedicated folder, and I'll name it game.html. I'll then drag it into my text editor of choice, which on Windows happens to be Notepad++, and I'll paste in some boilerplate HTML, and then I'll immediately test my code so far, dragging it into the browser, and you can see if we open up DevTools, there's no errors. The page has exactly what we expect, which is nothing except for this title here provided by this element here. So next you might expect that I'm going to define the canvas here in HTML in the body, but in fact we are going to be programming the canvas in JavaScript and appending it to the body with JavaScript. And there are a couple advantages to this that I've found. Namely, you can change the width and the height and things like the aspect ratio of your canvas in one place without having to manage it in two places. And you can do some nice math to manipulate it in different situations, like maybe you are detecting the viewport size of your user's device, and you want to scale the canvas accordingly. And it's nice to have defined the canvas in JavaScript to accommodate this. So as we go in this first tutorial, this script tag will get rather large, but we do intend to circle back and pull out some of that reusable code and put it into some dedicated JavaScript files that we'll save in a subdirectory of our project folder called JS. So let's get started. The first thing I want to do is set a variable that will hold our aspect ratio. And if this were a normal game that I intended to release, I'd probably pick an aspect ratio of 9:16. That being height to width. So width bigger than the height. And that matches most modern monitors or tablets flip sideways. But as we're going to be testing over here in Chrome on half my screen, and really only using half of that even since we have the dev tools open, we're going to flip this aspect ratio and make it 16:9 height to width. So the height will be bigger than the width. And as I indicated, we have about 500 pixels to work with in the width, and the height is going to be a function of the width and the aspect ratio. So now that we've got our dimensions figured out, we can use them to dynamically create a canvas element with JavaScript. To do that, we'll first create a variable called myCanvas, and we will store in it an element that we create with the documents create element method. And that takes a parameter of the type of element you want to create. In this case, we want to create a canvas, so we have to type the word canvas. Next, we'll set the ID of this canvas, and maybe we'll call it game canvas. I do want to indicate that I did pick a different word for the ID and the variable name, and I specifically did not name them canvas, and that was solely to show newer users that the ID and the variable name are completely arbitrary. I made them off the top of my head, and they do not have to be called canvas. I've seen some other tutorials where they name everything canvas, and some newer users might think that's a requirement, but it's not. So next we will define the width and the height of this canvas using those global variables that we just created. And now that those are set, we can append this canvas to our document using the document method again, or the document object, and accessing the body and calling the append child method. And of course passing in that variable myCanvas. So this is a good time to save and refresh. You can see we don't have any errors, so that's good. Not a whole lot going on, but that's what we expect. Canvases are blank, so we can't really see them with the naked eye, but it is there, and we can prove that by first of all clicking to the right, viewing the page source, and you can see, well, there's no canvas in the body according to this, but this is the HTML that was served to the browser with the initial request. The HTML has since been manipulated by the JavaScript, and you can right click here, you can see I am on the canvas, you can see a context menu specific to an image, and if we inspect this, it shows us the current DOM, and there is a canvas element within our body. Okay, so let's do something a little bit more exciting than having a white screen. And to do that, we need to get a handle on the context of that canvas element. So we'll create a variable to hold that context, and we will access the canvas element by using the getElementById method on the document and passing in that game canvas ID name that we picked earlier. And now that we have selected that element, we can call the getContext method on the canvas, which takes a parameter, in this case 2D, since we'll be drawing 2D shapes like circles and squares. So next, how do you do that? Well, there's a nice method provided to us on the context called fillRect, which takes 4 parameters, x, y, and width and height. Just want to point out the xy is top left oriented, so this point is 0, 0. X gets bigger to the right and y gets bigger downwards. Doesn't exactly match the convention we're used to from regular Cartesian coordinate systems, but that's the way it is in most graphical programming, so get used to it. So we will save this and refresh, and we should see a black rectangle as big as we've defined the canvas, since we are using the dimensions of the canvas for drawing this rectangle. And it is black since that is the default, and which fits nicely with our space motif. Okay, so next maybe we want to draw another shape on top of this black background. So again, we can use the fillRect method, and we can shift the x maybe to the right 100 and down 100, and maybe we want to make it a square that's that has an edge of 100. And we saved and refreshed, and we don't see anything though, and that's because it's the same color as the black background. So we can set that by calling fillStyle, and maybe we'll make this rectangle red. Happy little rectangle, exactly where it should be. Okay, so maybe we want to draw a nice yellow frame around this red rectangle. We don't want to fill it in, we just want a nice yellow frame perfectly encompassing that rectangle. So how we'd go about doing that is, this time we wouldn't call the fillRect method, we'd call the rect method, which takes the exact same kind of parameters, an x and a y and a width and a height. This time, since I said we wanted to perfectly encompass it, maybe we'll start off more to the left and start off more up, and we need to make it, you know, this particular rectangle started at 100 and was 100 wide, so it ended at 200. We want to end at 250, so this thing needs to be 200 wide and 200 tall. Now we'll save and refresh, and again you won't see anything because we actually haven't stroked the lines to this rectangle. We've only kind of defined it in memory here. And you have to call the stroke method to draw the shapes that you've defined that are still in your buffer. In this case we only have one, but you could define multiple shapes and stroke them all at once. So again, I'm going to save and refresh, but again we won't see anything. Well, first of all, because I have a typo, but we'll save that and refresh again, and we won't see anything. And that is because the default line color is also black. So in order to change that, we have to use the stroke style set the stroke style property rather, and we'll set it equal to yellow. And as you can see, we've got a nice little Rasta theme going on here. That line is a little thin. Let's make it thicker. And you do that by setting the line width property, and we'll set that equal to, let's say, 10. And now we have a thicker yellow line. So demonstrating drawing the exact same line again, but this time say 5 pixels. And actually, let's not draw the same line over the old one. Let's try to draw one below. So we need to shift this whole thing down. Let's see, we started at 50/50. It was 200 big, so this is 250. Let's put a 50 pixel gap and start it at 300 down, but still 50 to the right. And let's make it green. Now what we're going to see is a green box be drawn below, but we're also going to see a green line inside of the old one we drew. And that is because we haven't begun a new path. We've actually stroked both of the things that are in memory. So this was in memory still, and this is newly in memory, but since I called stroke, we actually stroke both of them. So if you want to avoid that, you would call the context.beginPath method. And that will alleviate us of that problem. And this also applies to things like filling. So you can see here we have an empty rectangle, but maybe we want to fill it as well. Well, you might say, well, why don't you just use the fill rect method? Well, this is a very special method which actually takes care of beginning your path for you, and it always fills it. I personally like to create helper methods which you can set all those properties on. Sometimes you want to just fill it, sometimes you want to stroke the line as well, sometimes not, and also sometimes you want to fill the box and then stroke the line, sometimes you want to stroke the line and then fill it, and we'll talk more about that later. But in the meantime, let's look at what happens when we fill this box as well. So what we should see is that this green box fills with red, the last thing we've defined as our fill style. And sure enough, that's what happened. Now if we remove the begin path, we'll also see this rectangle fill with red. And that's because, again, this was still in memory when we called fill. So let's talk about the last thing I said about filling first versus stroking first. And I'll put the begin path back so these shapes are unaffected. And now we will maybe make this a little bit thicker so it's more profound what I'm about to demonstrate. So now we have a nice thick green line. But it's actually, look at that, it's not even as thick. Well, let's make this exactly even. So this line width on here is 10, and now this one is also 10. As you can see, this one's gonna look smaller than this one, and that's because we've actually filled after we've stroked. So we stroked the line, which essentially draws a line where the exact center of the line is on the dimensions of the square. So there's going to be 5 pixels above that and 5 pixels below. In fact, if you make this number rather large, you end up with something a lot bigger, maybe filling up your entire screen. You generally want to avoid that probably, but maybe it has some use in your game. Okay, so but what I wanted to show there is if we actually stroke second, we will see that line now is going to be exactly equal to in width of the yellow line, and that's because now we have, oops, I didn't save. So now we have filled this first and then drawn that line on top, so the green line ends up on top. Okay, so next a good place to go to might be drawing a circle. So let's draw a nice circle down here below all these things. And again, we're going to begin path, so I can just show you the basics of drawing a circle, but then I will comment out the begin path and show you something that's also special about circles when you don't begin the path. Okay, so in order to draw a circle, we'll use the arc method, and the arc method takes several parameters, the first being the angle at which you want to start at, I believe, which is 0, and the angle you want to end at, which is 360. I'm sorry. The first parameter is always the x and the y. So in this case, and I didn't indicate this before, but when we define the x and the y of the rectangles, it's the top left. So this was 50 and 50. This was 50 and whatever, 300. So with circles, though, we don't define the top left. I mean, that'd be a strange place to calculate. Quite naturally, we pick the middle of the circle. So in this case, if I want it like nice and lined up with these, I need to figure out where the center of these shapes was. So if we started off at 50 and it was 200 big, then half of 200 is 100 plus that 50, so 150. So we know our x needs to be 150, and we know that our y, in order to go down far enough without touching these, and maybe also leaving a 50 point pixel gap in there, we'll do a little math on that. So this thing started off 300 pixels down, and then it's 200 pixels big, so that puts us at 500 right here, plus another 50 for the gap, plus whatever our radius has to be. So again, 500 to 550, and our radius of the circle, in order to match the size of those shapes, would have to be 100. So 650 is where we want to start, and the y. And as I said, the radius will be 100. And next we will pick our begin point of the circle to start sweeping out our circle, and that will be the 0 point, and that would be the point at the very right side of the circle, and then from there we'll sweep downwards and all the way back up to 360. Now unfortunately we can't use degrees, we have to use radians, so I'll get a nice little helper method for us and paste that at the top of our code. Something some people might understand is ugly, but we'll come back later, as I said, and put some of this functionality into proper JavaScript files. For now I just want to illustrate the circle, so we'll put that up there, and now we can use this method to pass in the proper amount of radians to sweep out this circle. So I save, I refresh, and again we don't see anything, and that's because I haven't stroked the line of the circle. So we'll call context.stroke and refresh, and now down there we can see a circle nice in line with these. It also has a green line since that was the last stroke style defined. So now what happens if you don't begin your path? Well, the last square we drew was stroked, and it went down, right, up, and left. In fact, maybe it went right, down, left, and up. It doesn't really matter. In any case, it ended where it started. So when you don't begin your path for circles, what happens is you can imagine the pen that stroked it is still pressed to the paper, and the next circle you draw, we kind of bring our pen all the way down to where we knew we were going to start the circle, and then we begin sweeping the circle. So we'll end up with this interesting line coming down. It looks rather awkward. And if we were to set the fill style of our new circles line and say, not fill style, let's say stroke style, and say that it's equal to pink, let's say purple, and maybe it has a thinner line width again, so context.linewidth equal to, let's see, the last one was 10, let's make this one 5. Now again we'll see the old square gets a purple line on the inside of its current green line, and then from here it will just be a purple line all the way down around the circle's purple line. And sure enough, that's what we get. Okay, so I think that demonstrates a lot of the basics. In the next video, we'll demonstrate how to rotate these shapes around different parts on the shapes, and we'll demonstrate drawing an image to the screen. So we'll save an image in our game folder here, and we'll access it and draw that to the canvas as well. After that's all done, we will pull out all the reusable parts of our code and create a draw JavaScript file so that we can begin programming things in our main script, maybe like a game loop or an animation loop or something like that. Okay, so thanks, and don't forget to like the video, and stay tuned for the next one.